Hello, everybody. This is Mr. Bayona. I'm the environmental science teacher at Warren High School in San Antonio, Texas, United States of America. And I understand that you all are doing kind of an exchange program of information having to do with sustainability and sustainable growth. I looked through some of the projects that you had shared with your other peers and decided that we had done a project over agroforestry that I think fit in pretty well. Although it might be a little bit more specific than some of the things you've been doing. So let's go ahead and take a look at it. And the difference between the PowerPoint that I gave you in this presentation that you're going to go over is that there are videos that are embedded in this presentation that you're going to be able to watch. All right, so what was the purpose? All right, so we're mostly suburban kids, and so we don't really have a whole lot of information and knowledge about where our food comes from. But I do tell the kids that when we learn things that I always want to be able to apply what we learn to our daily lives so that way we can kind of improve the environment and our society as a whole, right? So when we got into agroforestry and we started learning about feeding the world, we had to learn about where our food currently comes from in order to sustain gigantic populations that we have now. With the help of the Industrial Revolution, populations have been able to grow exponentially at a really, really high growth curve. So food technology has had to keep up with that in order to make sure that we can still feed our population. So we've had to do things like genetically modified organisms and crops to increase yield. We've had to mechanize agriculture so we can harvest quickly. And we've had to do some kind of creative things, inventive things with irrigation so that we can grow in places that don't have a whole lot of water effectively. Okay, we've also had to clear a lot of land, right? We've had to clear a lot of land in the United States. About 41% of land is used for agriculture. And in our study of biomes, we learned that there are certain biomes and climates that naturally have more resources for agriculture than others. But places that do have those resources and those nutrients, the nitrogen, phosphorus, potassium, and whatnot, they may be places that do not replenish their nutrients very quickly, like plains and grazing lands and things like that. So when we start looking at the problems of large-scale agriculture to sustain large populations, I wanted to start out with irrigation, and we went on a field trip to a small-time farmer, a local farmer, that doesn't have the same sort of business model, that doesn't have the same sort of growth and agricultural model that a large commercial farm would have. His name was Sylvain Claviere, and he is a person that I met at the farmer's market just downtown where I live in San Antonio, Texas. And I was very interested to see some of the techniques that he was using and how they're very, very similar to the things that my students learn. So what does he do to get around having to use gigantic amounts of water and deal with wastewater? So he just makes sure that he gets up really early in the morning and he waters at ideal times of the day, right? That's a very easy thing to do that anybody from any part of the world can do, right? Just keeping track of how hot the day is and making sure you reduce evaporation. Another way that you can reduce evaporation is by using drip irrigation. He used this irrigation tape, and you can kind of see some of his, that's a lightsaber. You can kind of see some of the pipes here if you kind of, let me zoom in a little bit. Okay, so you can kind of see some of these pipes right here. And they go underneath this tarp, and that way the soil, when it does get wet, is not exposed to the sun and it reduces evaporation. And that's very, very helpful. Okay, so let's see. And we're also reducing runoff and waste. And I'll go ahead and show you some of this right now.
Last mulch, which is basically a plastic film, the quality of your trash bag at your house. And you grow one time, when you harvest, it's go to the landfill. So it's massive amount of plastic. And it's organic or conventional farming. Both use the same. We use landscape fabric because I can reuse it for the next 15 to 20 years. The only difference is you have to do the holes at a certain size. We burn the holes at a certain. I told you that we wasn't using any pesticide. Do you remember?
And so we'll get to that whole pesticide thing in just a second, and we'll kind of show you some of the things that he does there. But here's another kind of way that he reduces his runoff, and we'll go ahead and look here. So this here, this is actually a crop. right? This is actually a crop. It doesn't look like it, right? Because it doesn't look like it has those traditional bare dirt and then green rows, that kind of like alternating pattern. But I want you to take a look at some of the things that he does to the shape of his land to make sure that there's not as much water runoff.
Do that because when it's raining, instead of having the heavy rain get rid of all our topsoil, you're losing also a lot of water because it's just getting fast down there. Those soils, they retain the water, so the water will fill those soils slowly and the water will penetrate deep inside the subsoil, so you got water available much.
So right there, if you can't understand the word he's using, he's talking about swells. He digs some ditches in the ground out in these regions over here off to the side. I don't know if you can see it, but this is actually a ditch with overgrowth. And as he waters, the water, instead of running off down this hill right here, down these gradients on the sides, on the perimeter, they'll get stuck in these little ditches and they'll fill up. And as they fill up, instead of running off, they remain in this area. So when the water gets depleted from this soil, from the sun, it'll actually infiltrate this way and then it'll water his land, right? So he's using kind of like a little bit of flood agriculture, but this is what we call contour plowing, right? So he's doing something where he's planning ahead so that his water usage decreases in the long run. So let's see if we can watch a little bit more of this.
Longer for your trees. Those trees never been watered after the first 6 months, and they're still very fine. We got peaches, we got almonds, olive, figs, all around. Those are pomegranates. We use them as windbreak because wind is very harsh for vegetables. Sometimes, you know, when they get move one size to another, it's bring a lot of stress, so it slows the growth. So windbreak, you can increase by 30% your production just by adding windbreak, and windbreak can be edible, so you're not.
And this is kind of a theme throughout his entire presentation that he had on this trip that we did, is that using the landscape to your advantage and using the plants that you grow to your advantage and thinking smart ahead of time are ways to not only promote growth of your plants and increase yield, but also to reduce waste of resources, whether that be fertilizers, whether that be water. So let's move on. Okay. So more solutions to large-scale irrigation. Now what I want you to kind of see here is that he is minimizing exposure to the sun, right? It is pretty hot here in this part of Texas, and when it's not hot, it's humid but without rain. So a lot of our plants, even the full sun plants, don't do too well in Texas. These are some full sun tomatoes that vine, and there's a reason why. He uses vining tomatoes. They have indeterminate growth, or they're non-determinate species, which means that they'll keep growing. They don't just harvest once per year. They're a little bit more cumbersome because they usually grow all over the place, but what he does to remedy that is, if you look very closely here, these are spools up here, like fishing line spools. And as his tomatoes grow up these lines, they'll produce tomatoes all along here, and he can harvest them, cut them, which means they'll just be a bare vine, and then he can drop it. He can drop the vine back down to the bottom, and the tomato can grow back up again and produce more. So that's kind of interesting. So look and watch some of the things that he talks about here.
Will always be on the top and growing. So instead of 3 months, I'm gonna raise them for maybe 9 to 10 months if the conditions allow me.
That's pretty incredible.
So is it a fruit?
Sorry?
He's asking is it a fruit?
If is it a fruit? Yes. Tomato, it's a fruit.
Yeah, because we had
it's a fruit, but in the vegetable family.
We had tomato, like kind of more bushy plants, and those they shout out the tomatoes all at the same time, and we had to pick them all at once, and that was it.
So most likely those are hybrid.
Yeah.
So you certainly never go for GMO. That's something you always want to have.
So Sylvain, he does a lot of his own production of tomatoes. He makes sure to selectively, artificially select tomatoes that do well in the climate and that are drought resistant. So all of these things that he grows, he's pretty much made himself over a period of generations of of the life of the fruit. So these are just other techniques that he uses to kind of reduce water waste. All right, mechanization of industrial agriculture kind of turns into something that we have to learn about in our environmental science class called a positive feedback loop. And that's where the effect is magnified based on the input, right? So machines make agriculture, which make agriculture fast, are very expensive, which means more crops must be harvested in order to pay for those machines, which means more land must be used, which costs more money, which means more food must be harvested, which means more machinery is required. So that's how that's kind of a positive feedback loop. The more of this machine I get, the more agriculture I have to do to pay for the machine. So it's kind of a recursive sort of thing, right? Below is a commercial tiller attachment, which is by no means the most expensive piece of equipment commercial farmers use. The tractor connects to it can be $10,000 to $100,000 or even more. And I have a video of Sylvain talking about kind of the plight of a farmer later and how much these things cost. So that there is $3,600 US, and that's far more expensive than pretty much anything Sylvain uses, and you'll see that now. All right, so what does he use? He uses this thing called a broad fork here, and I'm going to show you that. And the cost of using that, of course, is just his labor, right? And that particular broad fork, he told us cost about $200 or around that area. So let's see. Move some of this stuff out the way.
In sustainable farming, organic farming or conventional farming, most of the time they will till the soil. Do you know what tillage means? When the farmer till the land?
Oh, with the horse? Right.
That was before. There's not much farm using those anymore. It's becoming rare. A tiller, it's an attachment behind the tractor with blade that turning that way, you know. So it just break up and move the soil all around. When you do that, you bring back seeds, weeds on the top. You create a slab underneath, because each time the blade.
So right here he's talking about tillage and commercial tilling. Not only is it very expensive, but he's talking about kind of the spread and the broadcasting of weeds, of any sort of weeds. And if they seed, they'll produce more weeds. What the tiller is effectively going to do is it's going to chop and spread those seeds all over the place and integrate it into the soil. So you're essentially not only growing your carrots and radishes and lettuce, but it's almost like you're farming for weeds, and you have to continually till the soil in order to get rid of those unwanted plants. So this again turns into some sort of like a positive feedback loop where the more you till, the more weeds you get, which means the more you till. And this ends up having an effect on the soil beneath the tilling blades that he's talking about, where you create this slab, this really hard slab, which anytime you need to go water will just basically slide off that layer of sand, because you've compacted it so much that it's almost like a solid piece of impenetrable rock. So he's going to explain that.
Kick is 10, 12 inch or 20 inch. It's create a slab. So what it does when it's rain, the water is going to infiltrate very fast because the soil is very loose on the first 12 inch. Once it's hit the slab, it's coming up. So when you drive after a big rain, heavy rain, look on the big field, farmers growing corns or other things, and you will see a lot of erosion. That's because of over tillage. It's very damaging for the soil, and that's the main reason we don't support organic farming, because they allowed tillage and it's very damaging. When you till, you also release a lot of carbon dioxide, which is one of the main climate change issue. So by don't tilling, we allow the microorganisms to digest that carbon dioxide. And that's what we use to replace our tillage. It's called a broad fork. And the way we use it, we just put it in the ground. And once you reach the diff, you just lift. That's it. So we don't invert the soil layer, we don't break the soil structure, we don't kill any life, we just aerate underneath. And we come back. You take it off, you come back a couple of inches behind, and you keep doing the same.
What is that tool called?
A broad fork.
Broad fork.
That's it. You don't check, you don't turn over, that's just what you need to do.
I see some of y'all eating with that in the cafeteria at school.
And you do your entire bed. Once we've done that, we will usually do a quick weeding, like mostly for that. So that's, anyone know that thing?
Type of grass is that? Anybody
That's
know?
called Bermuda grass. So that's a non-native grass. It comes from Africa. They introduced it in Florida because it was nice, short, and stay green on the summer heat. Then they bring in.
So remember that term, non-native grass, non-native species, because that does play a role in some of the things that he does in order to reduce his costs and maintain biodiversity. So let's go ahead and take a look at the next part here. And this is one of my students. Actually, this is one of the students I invited from one of the science clubs from the school. They meet after school, and because of this field trip, she's going to join the environmental science AP class next year.
Oh, not like that, not like that. No, I'm just kidding. Gotta rock back and forth. Use your whole body. Nope, not that way. Side
you
to
like
side.
go side to side.
Rock your whole body. There you go.
Don't you like rocking?
Like you're skiing.
What's worth noting here is this video that I'm showing you happened chronologically. She had just seen Sylvain use it, and this is kind of one of the struggles that I'm sure all teachers have to go through no matter what part of the world we're in. Is doesn't matter how many times you show a student how to do something or how close they were to the example, they want to experientially try it out their own way.
No.
No, wait, I thought you just do it like that. Yeah, you can. Oh.
Yeah, you're gonna fall.
Wait, what do I do then?
Yeah, you got it. That was good. That was good.
Yeah, a little bit more.
There you go.
Come pull out my roots. Wow.
Yeah, who wants to go help pull out the Bermuda grass? Get some of those stems by the.
You have to take it at the base. So any weeds that you remove, you want to grab it, you want to find the base, which is here. And once you have the base, slowly chip it and pull as much as you can.
Physics, nice and slow. That way it doesn't snap at the.
If you go fast, you break the stem. And if I break, for example, that little thing in 3 stems like this, all those will regrow and come back.
Wow.
It's the end.
He really recorded it.
Try it. Go grab it. Yeah, it's like when you have like a rope tied around something, you pull it fast, it's gonna yank and break the rope instead of pulling out what you're trying to pull.
Gabby, just
You gotta slowly kind of wiggle.
can I do it?
That's a carrot, Gabby. No, I'm just kidding.
Really? Stop.
You got it though. Look at that.
Wow.
Look at that glorious one. Really hold your catch next to you like that.
So you can kind of see the difference between just going over and tilling everything with some sort of large mechanical device. And though this does seem really slow and cumbersome, Sylvain is not working on gigantic pieces of land. He's working on 5,000 square feet, about 460 square meters worth of land, and he's making a living off of it. And so we'll see that in the next slides too. So I just talked about land, but this is some of the usage of land that we were talking about earlier, where 41% of our land in the United States is for farmland. In Texas, we have a lot of open land. This is a farm plot out in Houston. It's about 35 acres. 35 acres is 14 hectares about, or about 0.14 kilometers squared. But this is by no means a very large farm. We have one of the largest farms in the entire world, owned by a company called King Ranch. And it has 4 large properties in Texas, out in Kingsville, but it also has some land out in Florida, which is the peninsular state we have out in the east there. That ranch is 825,000 acres, about 330,000 hectares, or about 3,300 square kilometers. 242 square kilometers of that is just agricultural products such as cotton, and the rest is going to be ranching cattle and horses and things like that. Ranches of these size are worth somewhere between 500 million up to about $1 billion is what one of the farms in King Ranch was worth a few years ago. That is a lot of land, and it makes a lot of money, right? So how do you compete with that as a small farmer? So those large values of those farms come with astronomical costs of labor. You have to employ a lot of people. You have to mechanize it to be able to efficiently harvest your crops. And you have to transport materials. You have to ship those things out, which, as Sylvain was talking about earlier, CO2 coming from those microorganisms at the ground also comes from the combustion of fossil fuels, right? And the further you have to take your product to get sold at market, the more your carbon footprint is going to go up. Sylvain and other local farmers make their money by keeping their costs low and their land usage efficient. And they sell their wares, they sell their products, their produce at local farmers markets, where people come from maybe 50 to 60 miles away to sell their food, instead of having cotton and avocados, tomatoes, apples be shipped from California all the way to Texas, 1,500 miles. We're having things bought locally, right? And some of the things that you lose out as a result of buying locally is you don't always have tomatoes and apples in season, right? When it gets down to, close to 5 degrees Celsius, you're not going to have tomatoes near you, so you end up having to ship them from South America or from some other latitude that has a better climate at that time of the year. And while that's really nice and convenient that you can go to the shopping market and get fruits and vegetables from anywhere in the world any time of the year, when we're talking about sustainability, we really have to consider, is this a good choice to make? Is it good to kind of be able to, eat a tomato salad whenever I want? Or, do we need to make decisions that are better for the longevity of the planet, right? So now let's look at what Sylvain makes, right? So with just his wife, who runs all the social media, helps him farm, the intern, which was the woman you saw in the background earlier, you saw in the background with the gray tank top, and himself. So it's just 3 people. He makes he said he makes on average around $70,000 a year using only this amount of land, 464 square meters of land, which is not very much at all, right? And you're going to see in this clip right here, he talks about a specific value that he makes off of this plot of land, which is 10 by 50 feet, 10 by 50 feet. So let's see.
Always working outside every day?
Yeah, until June. After June, it's getting hot. I go back home.
Yeah, in June it gets hot, not right now.
Wow.
Yeah.
And I had to say that because at this point my kids were being little babies about being out in the sun. I told them for weeks that we were going to be out on a field trip at the beginning of summer for 2 to 3 hours in the sun to dress accordingly. And if you look at some of the attire of some of my kids, they're wearing like black spandex and things like that. And I think I was the only one with a hat. So I think that's just what happens.
Yeah, it's mostly after the change. Always your time always change. So
She must have passed out.
yeah, so you don't want to touch those. Those they're gonna be painful.
Oh, and I stepped on them. What are y'all looking at?
Okay, here's the point where he talks about the cost of mechanizing agriculture.
It's true. If you go to basic school, agricultural school, most likely you're not gonna make money farming, because they're gonna teach you how to use tractors, EV equipment, chemical, and all that's going with that. That's a huge invest. So that's a credit loan, $200,000-$300,000. That's gonna take you 50 years to pay it back, and once you pay it back, there's nothing left. It's gone. My farm, we invest maybe under $20,000. We start from zero, so everything that we invest, it's from vegetable that we start to sell, that we reinvest. So now we are on our 3rd year, and we start to make profit on it. And we don't have to spend anything. We don't own tractors. We own what is called a walking tractors. So you walk behind, but I make us build the beds, shape the beds, and all those tools. A broad fork costs $200. A tiller costs maybe $8,000 to $12,000, to give you an idea. So with that type of farming, you can make profit on a small scale land. You don't need to own 100 acres. On that plot, that's 5,000 square feet where you see the tarp. From the white tarp here to the other white tarp, that's 5,000 square feet. To give you an idea, a full bed, they all 50-foot bed, they all 30-inch wide, because that's all the tools that we use in small-scale farming. All those low-tech tools are made for 30-inch wide. The path it's either way from 12 to 18 inch. That depends how small is your place. If you have a very small yard, you can do 12 inch.
So off that plot right there, he talks about being able to make over $40,000 if he farms it correctly. And so that's something that my kids thought was very amazing, right? Because most of their parents, most people in the United States, the median income is under $30,000 a year. It's just around $30,000 a year. So that's making $40,000 off of something that's smaller than the land somebody's house sits on is something that most of my kids thought was very interesting.
If you have more space, 18 inch, it's much easier to work. You can sit and bend on both sides without breaking a plank. Square feet can bring you over $40,000. In that bed, in the right condition, it's $600 per harvest. So one bed potentially can bring you over $2,500. One bed. In that 1,000 square feet, there's 21 beds. So who can do the math? 21 multiplied by 2,000 to make it easy. 42,000. So potentially, if you have a great rotation and a great way to grow, that 5,000 square feet can bring you over $40,000. The best small-scale farmer now that I'm still learning from, they can do $150,000 on 1.5 acre. They do $350,000 on 2.5 acre. Just to give you an idea.
They don't use tractors or anything.
They don't use tractor. They don't use anything. Everything is done by hand.
That's awesome.
If you see my bed of carrots, I have 7 rows of carrots in my bed. If you look at the organic or conventional farm, they will have most likely 1 to 2 rows of carrots. So already there on the same spacing, I am 7 times more productive than they are. So if they own 70 acres.
So with that high efficiency and productivity, there's a very high demand for those nutrients to be there in the soil. So now he's going to talk about how he sustainably manages his nutrients. All right, and that kind of goes with biodiversity, maintaining biodiversity. So the first video I showed you, the first picture I showed you when he introduced us to his farm, he calls that area the food forest. He uses symbiotic relationships of plants, and he uses nutrient fixing plants such as nitrogen, phosphorus, potassium, based on whether or not he's using a nasturtium or hairy vetch or something like that. He attracts predatory insects by having flowers and whatnot there, and he reduces the need for pesticides and fertilizers, which, as we know, when they come into contact with human beings, whether they're from directly applying it, aerosolizing in the air, or running off into water later, they have a huge effect on not only the environment but on the human condition. All right, and then he shows kind of what he does with his waste products through composting, right, and reducing the need for fossil fuels, which, as we know, increase our carbon footprint. So let's look at some of the things that he does here.
Here we got the pomegranate. Next door we have artichoke. Then here we have, that's a hyssop. It's a medicinal plant and it's a herb as well, and it attracts bees. Bees love it. So we put it around the garden everywhere. That's why we never pollinize any flower by hand. Bees and bumblebees do the work for us. And we got artichoke again. That's a pomegranate again. Those are nasturtium. That's an edible flower that chef really likes. They're sweet and spicy peppery. So that's a great revenue. It's also trap caterpillars. So instead of eating your vegetable, they will go on those first. So you rather lose those than lose your vegetable. And that's chamomile. That's a great medicinal, a great tea as well. And it just keeps going. So we try to be the most efficient as possible on our bed, to grow the most food and diversity as possible. Without diversity, nothing will work on the farm. Like, we got hit 3 times by the hail the past 2 weeks. If I will grow only squash, I will lose my entire season. So I won't make any money for the next 6 months. But because we grow a lot of diversity, then when you got heavy rain, hail, snow, flooding, drought, you always have plants that's gonna do better than others, and you will always have something to eat.
So right there, he's talking about maintaining biodiversity not only to make money off of his crops, but to maintain the health of the ecosystem there, right? And so that's kind of one of the nice things about being conscientious about the environment as you do your agriculture, is that biodiversity and maintaining ecosystem stability is not something that is outside of the realm of economics and making money off of agriculture, right? And they can actually go hand in hand. Okay, so let's see some of the other things he does here. If you look in the background, I think I just meant to use this as a picture, but this was the tarp that he showed earlier, and this is where he makes his money. But if you notice, he has the exact same plant barrier out here in the background where the tip of the lightsaber is hitting. So he has that same windbreak there. He has those nasturtiums that are going to capture the caterpillars and things like that. And he has a lot of crop diversity here just in case something happens. Okay, let's see. Now let's look at some of his nutrients, like how he deals with his nutrients.
Compost at the school?
Yeah.
Do you do compost at home?
No. No.
Yes?
Use your own food.
I used to.
No.
You used to. Why did you stop?
I moved over here and I couldn't find a place to make a garden anymore.
Okay, you don't have a yard? Ah. Anyone else do compost? Yes?
Mm-hmm.
You still doing it?
Mm-hmm.
Oh, I do. I have
Yeah?
a farm in Mexico.
Okay, good. So there's many ways you can do a compost pile. There's no really rules. I did that one mostly to show people that they can be done in small space and stay pretty clean. So I just get a 50 gallon drum and I make hole inside because you want the compost to breathe. And inside, that's where I just jump my food scrap, you know. It's a bit heavy, I can't take it. But I will just put food scrap and I add dry material as well. Then when I put the bucket, just close it. Make sure that it holds. And this one I can spin it.
Some ideas for the science club.
And why we want
We
to
should do that.
why we want, you know,
That's
need
what
to
I
spin
think we
it,
should
but
do
if you do a
trash
compost
cans,
pile, you need
they
to
want
aerate it.
inside.
Because a compost that is aerate will decompose much faster than if you don't touch it. And that's very easy, you know, you just turn it, you don't need to break your back to take it and throw it, right? So that's one of the way we turn our compost. And I'm gonna go a little bit down.
I think large cities and stuff will usually use like these big like drill things. I don't know, like these gigantic troughs of like dirt like they have over there. And this is so much easier. It's just shake it and then move and then have it hit somebody. I'm just kidding. Yeah, it's big, right?
This thing really, they were mostly eating grass. But I was doing a compost, a specific compost that attract that guy. Have you ever seen those in your compost or anywhere? So those are called the black soldier fly. So it's a fly a little bit bigger than the house fly. They don't bite, they don't stink. Everything. They separate the compost, which they sell as a compost for the garden, and they separate those guys, which is very high protein, very, very high protein, and they give it for feedstock. So to feed cow, chicken, fish, anything. So I was having a compost over there, which with a ramp, because that things when it become mature, they climb no matter what. So in my compost there were a ramp, and they fall in a hole into the bucket. So every day we're harvesting a bucket full of those, you know, like thousands of those, and just and that's what they do, you know.
Where's the big
That's what they create, you know. That's 10 times better than the compost you will buy in nursery.
You guys notice how quickly your seedlings all sprouted up in your eco columns and stuff?
Yeah.
Because you're using basically the same soil
Yeah.
he's got here.
That's the best of the best. And what
I'm scared
we
to
do
go
with
by
that,
shoe.
we do the composting with an over barrel. So I put some of that in a tea bag. I put in a 50-gallon bucket full of rainwater. If you don't use rainwater, if you use tap water, that's fine. but you want to let it sit at least overnight that the chlorine will evaporate. Otherwise, when you put your compost, it's killed the microorganisms right away. And we aerate the water for 24 to 48 hours, depending on the season. That's why we multiplicate all those microorganisms. So for example, from here, if I have 1,000 microorganisms, after 24 hours aerated, I can have 1 million. And we're gonna spray leaves, ground, anywhere just to bring a lot of microorganisms. So we use 2 for our seedling, but we don't use it on our vegetable bed, because we can't produce enough, obviously.
What is that red stuff?
That's the Swiss chard again.
That's the Swiss chard.
So here he's talking about the multiple uses he has for his fertilizer, right? So it's not only just to increase the nutrients to his crops, but the useful microorganisms and the bacteria in the soil he uses to kind of make sure that there's a nice balance all over his property, so that harmful bacteria and harmful fungi and things of that sort can't take over, right? It's all about making sure that you have the correct balance of things there. He talks about making sure that you put wood chips on top of flower beds, so that way you don't have an overabundance of bacteria. You get a little bit of that fungus that you have there. And that's one of the main reasons he doesn't use pesticides and herbicides, is because if you have the correct microorganism ecosystem balance in your soil, it's going to keep a lot of those things you wouldn't want in your crops at bay. Doing things like creating monocultures, where you're just growing one type of crop, you're growing all corn, all melons, is inherently going to be something that needs pesticides and herbicides, because you run the risk of having some sort of mass infiltration of fungus or bacteria, blight, that goes through your entire crop. And so those farmers on gigantic plots of land that don't have the time to put in care to make sure the ecosystem in the area is balanced will have to resort to using pesticides, herbicides, fertilizers, right? So that's one of the other benefits to the small time farming, is you're keeping everything contained naturally. So that's pretty much it. That's some of the things that we did in this class this year. We learned about how to be sustainable, but most importantly, we learned about how to kind of apply that to our daily lives. A lot of our students, we come from an area of San Antonio that's pretty diverse. We have some people that are a little bit higher, they have a little bit higher affluence, right? They have a little bit more money. Their families are a little bit more well off. We have some people that aren't, right? But the thing that kind of unites us all is that we live on the same planet, and we have to make sure we take care of it in the ways that we know how. As our populations grow around the world, and as countries that we're developing, start to reach and even surpass the United States, it's very important that we try to learn the lessons from our growing pains from the Industrial Revolution onward, and we try to apply those to our daily lives. That way we can be more sustainable. One of the arguments that we make in our classes is it fair to put high demands and high standards on the developing world? Do we expect China, do we expect Russia, do we expect India to have to develop solar panel technology and forego going through oil, coal, natural gas, just because now we're equipped with the knowledge that it's bad for the environment? Is it fair to kind of have those expectations on the developing world? Or is it something where we should kind of help each other out and try to do things that are very easy to be sustainable, right? And so I hope you got to kind of look at some of the things that we're looking at moving forward with agriculture, and you can fit them into your tool bag of sustainability for the future. If you have any other questions, feel free to email me. Thank you.